You are welcome to this class. Today we are talking about chain rule. If you are new to this group, to this YouTube channel, try to subscribe in case I'm releasing another video. You're able to meet it up. So today we are explaining what we call chain rule in calculus. In calculus, it's split into two. We have differentiation and integrations. So we must start from differentiation. As we're explaining differentiation in calculus, so there's some parts we call it a composite functions. So inside the composite function, the function of a rule, the function of a functions, that is where we use a composite rules. But that's why we now use the chain rule to apply. So today we are dealing about 10 examples in chain rule. So stay tuned in the way to let's be in the class. So that is now chain rule. What are the analysis of the chain rule? He said the chain rule, he said if G is differentiable at x and f is differentiable. No, you can pick the call. As differentiable that I'm here. Is differentiable at g of x, then the composite function, which is f, is equal to f of g. Defined by f of x is equal to the f of g of x is differentiable at x, and derivative of f, that's the meaning f prime, is given by the products. So what are they explaining? So the first terms that there now is, the first term is, he said, the derivative of x will give you the first derivative of, you will not differentiate g of x, you will now multiply it with g of x. But in Leibniz notations, in Leibniz notation, if y is equal to f of u and u is equal to g of x are both differentiable function, then what I just trying to explain at that junction is, if y is f of u and g of x, u is g of x, it lets us to know that if the both, they can differentiate the both, then the y dx, the x is equal to the y the u the x. So this is just the explanations of this, that the moment the both are differentiable, you can differentiate the both, meaning that, so what I'm just trying to say now is that I'm now trying to solve the example. In the process of solving this example, we make it to understand it better about of this chain rule. So let's start solving the example now. Let me go to example 1. Example 1, it said find f of x if f of x is equal to square root of x squared plus 1. Now, in solving this, he said if f of x is square root of x squared plus 1, you can still rewrite to say that our f of x is x squared plus 1 all raised to power 1 over 2. Let's back to our story. It let us to know that from I'm going to use the both method to solve it. You now get the way that it is easy to solve with Leibniz notations and the normal composite functions and functions of rules formula. So therefore, you firstly differentiate the f of 1. You will input the g of x. You now differentiate the g of x. What is even the g of x? What is even the f of x? That is the most important thing to know at this junction. What do we call g of x? What do we call? Now, the f of u is root u or u raised to power half. The g of x is x squared plus 1. And as the formula said that, he said you first differentiate, you leave g of x, you now multiply with g of x. This is just the formula. So in solving this, it means that this is our question. He said f of x is equal to x squared plus 1 all raised to power half. So in applying this formula, what you are now going to do is this. You said f of 1x will be half x squared plus 1 onto 1 minus half dot derivative of x squared plus 1 with respect to x. If you're able to get what I'm trying to explain here, you firstly differentiate the f of 1, leaving the g of x, but later you will now multiply that's what we call it function inside function. So by the time you now multiply with the derivative of g of x, so therefore it will now be half onto x squared plus 1 raised to power minus half dot. So the derivative of g of x will now give you 2x. You see that 2 here we cancel 2. It will now remain, meaning that f of 1x prime will give you x squared because 2 has cancelled plus 1 all raised to power minus 1 over 2 dot x. But to recall from the fact of indices in elementary maths, he let us to know the one fact that a raised to power minus n give us a raised to power n. Therefore, in writing the f of s, it will give us 1 over s squared plus 1 dot x all raised to power half, meaning that the derivative of x is now x over s squared plus 1 all raised to power 1 over 2. Therefore, this is the final answer for this. This is just the first method. Now, I'm not going to use, I'm able to have written some story here that in Leibniz notation, he said if y is f of u and u is g of s are both differentiable function, then dy dx is equal to dy du dx, meaning that they multiply. So now, let's now apply the second method in the questions. Second method. The second method, they said the same question, said if y is square root of s squared plus 1. You now say that is the elementary way of solving this. You say let u is equal to s squared plus 1 and y is equal to square root of u. This is what we try just to explain. You now differentiate u with respect to x. From the beginning he said it to be 2x. The constant 1 will go, and you differentiate y with respect to u. Recall that this u is raised to power half. He said half u half minus 1, which is equal to half onto u onto minus half. You now back to the formulas, says that the y dx is equal to the y du multiplied by the u dx. Therefore, and your du, dy du is half onto u onto minus half, multiplying the u dx is 2x. Therefore, this will now cancel this. You now have the y dx give us u raised to the power minus half dot x. As I've said from the beginning, that from the law of Leibniz, it let us to know that it's 1 over u raised to the power half x, which is equal to x over square root of u. So in writing your final formula, you now say that your dy dx is now equal to x over square root of s squared plus 1. Let me re-explain this second method for you well. It said if y is equal to square root of s squared plus 1, let u equal to s. You can represent with any variable, but it is very common to be using u. Let u is equal to s squared plus 1 and let y is equal to square root of u. You now say that from the law of Leibniz, let us to know that the square root of u is u raised to power half. Therefore, the u dx is equal to 2x. Why is it 2x? Because the s squared plus 1, that one is a constant variable. It will go in differentiation because you have x to the power 0 value. Therefore, the y du, the half will multiply u, and half minus 1. That is how you now get the value of half u raised to the power minus half. Now, the y dx from the Leibniz notations, it let us to know that the y du is the y dx equal to the y du dot the u dx. You now multiply your answer together to get this value. So this is how this first example is being explained better. We are able to have seen this first example. You see what you're able to notice. I will want you, we are still solving something like 8-9 examples today, but I will still want you to, every areas that maybe you are having questions, just note it down. Send it to me in the comment sections. I will explain to you back. So that is example 1 being solved in 2 ways. So I will not be solving the next example. So the next example will also make you to get it better. So it will give a better way of getting it. So now let's go to the board to solve example 2. So you write as I'm writing to make it easy. So now the example 2. Example said differentiate A. He said y is equal to sine s squared, and B, y is equal to sine square x. Now you want to solve this problem, because there is no exercises. Every math question is a problem until you get the answer. Therefore, in solving A, you said y is equal to sine s squared. You said let u equal to s squared, and let our y is equal to sine u. Therefore, let's differentiate u with respect to x. It will give us 2x. Let's differentiate y with respect to u. It will give us cos u. By the Leibniz, because I'm not using the two method again, I'm using 1 so that by the Leibniz notation, let us to know that the y dx is the y du dot the u dx, which will give us what about the y du is cos u dot the u dx is 2x. But never do one mistakes. U and 2x are not the same. This one is measure in degree or radian. This one is measure in unit given, apart from degree. Therefore, you must rearrange to say that the y dx is now 2s cos u, which is 2s cos. What is the value of u? S squared. So this is the answer for A. This is how it looks like. So now, in the second one, he said y is equal to sine square x. You know, we have to back to some rules in math. So let us to know that sine square x can be written as sine x sine x. Therefore, y can be sine x all squared. So it will be easy for us to apply. He said let u is equal to sine x, and y is equal to u squared. So y now is equal to u squared. You now say, so you said let differentiate u, du dx is equal to cos x, and the y du is equal to 2u. By Leibniz said the y x, we apply this formula to this. The y du and the y du is 2u dot cos x. So therefore, what is our u? Sin x. 2 sin x cos x. So finally, this is the answer for this. You know, you don't need to make some mistakes. You need some mathematical logic way to solve some problems. So this is how to solve this, and this is how it looks like. So the both formula being used, we are still using the Leibniz rules to solve it. So I'm able to use the Leibniz rules, and I'll be able to use, I'm using the two rules to solve it. I've used the normal composite rules. I've used Leibniz to solve the first example. Therefore, that is how the chain rule deals You know, in calculus, especially in differentiations, you must understand the chain rule. Chain rule are highly sacrosanct to understand in calculus. So that especially in differentiations. So that is why I'm able to give explanation to this. Remember, if you just jam this video anywhere, subscribe to the channel Mike Bronze TV, where we give a mathematical solution, we diagonalize mathematical who mathematically heal. So let's back to the board and now going to the power rule combined with the chain rule. So what we want to explain now is power rule combined with the chain rule. Say the power rule combined with the chain rule. If n is any real number and u is equal to g of s, is differentiable, the u raised to the power n, it will be n this dot the u ds. Alternatively, the g of s raised to the power n will be n g of s dot. All what they are doing now is at the first example, but this one incur power rules. So how do you now want to solve this? Let us to know that let u equal to s to the power 3 minus 1 and y is equal to u raised to the power 100. If you're able to see, he said the y, the x. So what you are going to do is you just say that 100 we multiply s cubed minus 1. You will subtract 1 minus 100 dot derivative of the inner one, which I have done earlier with respect to s. As this is what they want you to write. This is how they want you to write it. The format so far. So whereby the y, the x will now 100 onto s cube dot. Now in differentiating this, the s cube minus 1 to give you s cube. So the final answer here will now give you 100 s squared onto s cube minus 1. So this is the final answer so far. So let me re-explain this. Maybe you can get it better. He said if y is, he said differentiate y is equal to s cube minus s cube minus 1. Therefore, you let the u to be equal to s raised to the power 3 minus 1, and y is equal to u raised to the power 100. From the formula that you're able to see from here, you realize that they first differentiate the u, the y on u. They now differentiate what is the u with respect to s. So this is exactly what we did. The 100 multiply the whole y, that is the u, and we now multiply with the derivative of s cube minus that 1. So we now multiply to get this answer. So this is how exactly it looks like. That is how. So we're in example 4 now. So in example 4, we now want to solve this. So if our f of x is equal to 1 over 3 cube roots s squared plus x plus 1. So what the most important thing you need to do is you firstly convert it to index form. You will write like this. Can you see? You now change it from the log to have s squared plus x plus 1 all raised to power minus 1 over 3. So if you want to solve this now, we are now going to apply our general formula that the f1 will be 1 over 3. You will write the g of x minus 1 over 3 minus 1 dot the derivative of the exact value with respect to x. So meaning that f1x will give you 1 over 3 onto x squared plus x plus 1. So this one will be, in a rough sketch, it will be minus 4. This is minus 3 minus 1 minus 3 over 3. It will be minus 4 over 3 dot. So by the time you differentiate this, we have 2x plus 1. So f1x will now give you 1 over 3 times 1 over x squared plus x plus 1 all raised to power 4 over 3 dot 2x plus 1. So your final answer here will now be 2x plus 1 over 3 onto x squared plus x plus 1 onto 4 over 3. So this is the final answer for this. So we can able to see this, that this is exact. So I just solved this one because we have been reaching some certain stage that you need to understand better, that if what you firstly do, you convert it to normal index form. The moment is in index form. So if we're able to see now, so that is the final answer. So now that is just, this is just this example, this is just the way it is. So this is example 5. How do we differentiate this? So solution. In differentiating this, g of t will be 9. You will write t minus 2, 2t plus 1, 9 minus 1 dot derivative of t minus 2, 2t plus 1 with respect to dx. So this is the advantage of understanding this. Now in solving this, so g of t will now give you 9 onto t minus 2 onto 2t plus 1 raised to power 8 dot. What you are going to do here is quite different. You apply what we call quotient rule. So in apply quotient rule, so this is u, this is v. And you know the formula before. He said dy ds is equal to v du ds minus u dv ds or v square. So this is a quotient rule. So now in applying this to quotient rule, say v du, you write 2t plus 1, 2t plus 1. Now multiply du ds. What is our u? T. So dot to the way of t is give you 1. Derivative of t minus 2 will give you 1. Now minus u. This is t minus 2 derivative of t minus u. I want to move this somewhere around here. Yeah, good, thanks. Now, so the derivative of t minus u, now that is u. The v dx, what is our v? 2t plus 1. We multiply by 2 all over v square. 2t plus 1 all in squared. Let me return it back because we don't need it again. So therefore, our g of x will give us, you still write 9, you open a bracket, t minus 2, 2t plus 1 all raised to power 8 dot, you open a bracket for this. So this one will give you 2t plus 1 minus bracket open 2t minus 4 over 2t plus 1 all squared. So in solving this, we now try to expand it better to have g of x to now give us 9 onto t minus 2, 2t plus 1 multiplied by, we have 2t plus 1 minus 2t plus 4 over 2t plus 1 all squared. So we have g of x, which is equal to 9 to multiply t minus 2 onto 2t plus 1 all raised to power 8 multiply this, and this will become 0. It will become 0. So plus 1 is 2t. Yes, good. So it will now give you, so it will now remain 1 plus 4, making 5 over 2t plus 1 all square. This 5 can multiply 9. We have g of x, which is equal to 9 times 5 onto t minus 2 all raised to power 8, 2t plus 1 all raised to power 8 times 1 over 2t plus 1 all square. I'm solving this step by step so you can get it clean and clear without any headache. So let's go to the next page. So the next page, we're only starting from g of x got to 45. That g of x is equal to 45. Onto bracket open. You realize that t minus 2 will now have raised to power 8. T minus 2 will now have raised to power 8. Let's recall something in indices. He said a raised to power n times a raised to power n. You can rewrite it as you have m plus n. So in the denominator part of this solution, you see that 2t plus 1 raised to power 8. 2t plus 1, they are common. Or equal. They are common or equal. So that is how it relates to this. They are common or equal. So that is how it relates. So therefore, it will now be 2t plus 1 onto 8 plus 2. So the g of x is now 45 onto t minus 2 raised to power 8 over 2t plus 1 all raised to power 10. So raised to power 10. So for this question, for the example 5, this is how it is being well explained, and this is just the solution for it. So it really gives a well explanatory and you're able to get it clearly as I did this step by step. So that is how to solve it. If you're able to apply it as in study it clean and clear, you discover that you will surely get the answer. So we still proceed to the next example. So try to write the notes, study it well, and any question from this stage, you will send it to me in the comment section. Any viewers, as you are watching the video, send any question to me. I will surely answer you. So this is example 6. But I now want to explain the example 6 now. If you're able to see this question is a product rule, which you can be able to say that this is UV. And you know from the product rule, it says dy dx is equal to v du dx plus u dv dx. But what exactly meaningful here is that we want to explain chain rule, and the chain rule that we want to explain falls under the product rules. So, but it means that we are not going to be using the elementary part of the chain rule. We are applying it stage by stage. So let's start solving this. In finding the y, the x, we have no first write v. He said x cubed minus x plus 1. You write the question ordinarily. Let me so now he said, so you try to write the question. So you write the v, you now differentiate u. If you want to differentiate u from what you are able to talk as before, we have, you further write 5. You write the question to have 2x plus 1. You said 5 minus 1 to give you 4. So dot the derivative of 2x plus 1 will give you 2. You said plus, this is this plus. So from here, you can now say plus. So when you say plus, so you now write u now. What is our u? Which is 2x plus 1 raised to power 5 dot. So dv dx, we have 4, we have x cubed minus x plus 1 so dot. By the time you differentiate the inner one here, you have 3x squared minus 1. So what I just want us to pass through here is ability to simplify. Let's study the question very well. We only have 1 plus, the remaining one is multiplication. So you see from here, when you put the plus, we have 3 here, sorry, there is 3 here. So this one and this, they are common. So if you take 1 out of this, we have, but before we take 1, there is 2 here, there is 4 here. You can take 2 outside. You also take this one is common. We have x cubed minus x plus 1. Let's also study that this is also common. 2x plus 1 is common. This is raised to power 4. 2x plus 1 here raised to power 5. Let's take the highest, the lowest one, raised to power 4. We now open the bracket. In place of removing this, you know you said x cubed minus x plus 1 is common. So in place of removing it outside and taking this one will now remain 1. You know you have taken out 2, it will now be 5 brackets x cubed minus x plus 1. So you know you have taken out 2 here, because taking out 2 here, so we now remain plus, all this one has gone, remain, you know this 4. You now have 2x plus 1 onto 3x squared minus 1 multiplied by 2. So in doing this, you have the y dx to be, you put the 2 outside, you have x cubed minus x plus 1 raised to power 3 onto 2x plus 1 raised to power 4. We have 5x cubed minus 5x plus 5 plus 2 onto 2x times this, we have 6x cubed. We have 6x cubed. 2x times minus 1, we have minus 2x. 1 times we have plus 3x squared minus 1, all into bracket. So you write again to have 2 onto x cubed minus x plus 1 onto 3 onto 2x plus raised to power 4. You have 5x cubed minus 5x plus 5 plus 12x cubed minus 4x minus 2 times minus 4x, yes, plus 6x squared minus 2. Now, let's now writing it one by one. So in case of writing this, you will now rewrite to have y dx is now equal to, you firstly write the 2 outside, 2 onto s cube, 2 onto s cube minus x, s cube minus x plus 1 raised to power 3 onto 2s plus 1 raised to power 4, 2s plus 1 raised to power 4. Now dot bracket open. Now what you'll be doing now is that this plus this will give you 17s cube. We have 17s cube. We have really about 17 plus 6s squared. Yes, is correct. Plus 6s squared. How? Well, this is s squared. Now you now add minus 5x minus 4x to give you minus 9x. Yes. So we now have plus 5 minus 2 to give us plus 3. So this is the final answer for that question. This is how the question is. That is the final answer. It's really amazing. The reason why we are solving this at a low way is that we need to explain it in a very simple way. Be able to see from the beginning that if you're able to study the example 6 very well, it's a product rule, and at the same time, being a product rule, we must apply the composite rules. That is what they mean by chain rule. So in applying the chain rule, we must follow all our procedure that we are able to have done since morning, since we have started this lecture. So now I would like to go to the next example, where I will be able to explain another way that you can pass through this. You can meet up some questions that is highly most important so far. So we need to go to the next example to explain better. So if you are still new, just come across this channel, don't forget to subscribe and to put the top up notification on. So let's solve the example 7. So in the example 7, the first thing I want you to know is this. The first thing you must notice is that if y is equal to e raised to power u, y prime is the same thing as e raised to power u. Likewise, the same. So here is just a note. So if our y is equal to e raised to power sin x, so the y, the x will be, if you differentiate all, it will give you e sin x dot derivative of sin x with respect to x. So the y, the x will now be e raised to power sin x dot cos x. So the final answer here is e sin x cos x. So that is just as simple as the example 7 is. So in the example 8, this a little bit complex, but I will explain it so you're able to get it clearer. Now what you want to do here is that you want to get f of x. It will be, if you only differentiate sin x, to give you cos, you write cos tan x dot derivative of cos tan x with respect to x. We have never reached where the s is. So therefore the f of x prime, y prime, will be cos onto cos tan x dot minus sin x, yes, minus sin. So here again, you have differentiated this, so it will now, what next to do after you have differentiated that one? So the final answer will not, because that is, it is not even the value of x. We have never seen the x, because where the x now lead the, sorry, let me write the way you will understand. Derivative of tan x dx. So f of x prime will now be cos, let's say minus, because this is this minus, onto tan x sine of sec square x, because derivative of tan x is sec square x. So that is the derivative. So now sine, because it is minus sine, and if you're able to see from the notes, set minus sine tan, sorry, you should still remain tan before differentiating. It still remain tan here, tan x. So tan x will now be, because you apply the formula twice, it will be, the final answer will now be minus cos onto cos tan x. It end up in tan x. So the same thing applicable to here, sine onto inside tan. This is the final one before you now differentiate the tan, because we differentiate in 2 times. You now have sec square x. This one, it is simple, but the only thing I will just let you to know that it's really, what happened here is that we differentiate, we apply that formula twice. So when you apply the formula twice, this is what it brings. So we are now going to the final example now, which we explain the last one. So what we want to, this example again, the example 8 is this another format of the example that we want to explain now. Is the same format. The first thing I want you to know that the derivative of, for example, y is sec x. If you are to differentiate the y, the x, it will give you sec x tan x. Try to note this. Now we now want to apply our formula. Let's say our formula here to say that y is equal to e raised to power sec 3 theta. And you know that if y is equal to e raised to power x, the y prime is e raised to power x. It's the same thing. So therefore, you now want to apply for this. You said y prime is equal to, firstly, e raised to power sec 3 theta dot derivative of sec 3 theta d theta. So now, what do you observe in this? In the sec 3 theta on its own, because it's supposed to be sec x, it's a function inside a function inside a function. The function are 2-3 times function. That's how you'll be doing that. So it means that e raised to power sec 3 theta dot the derivative of sec 3 theta on its own is sec 3 theta dot sorry, not, you don't need to write this, sec 3 theta tan 3 theta. Now with derivative of 3 theta d theta, you discover that if you notice this now, we now do it 2 times. Before we did it 1 times. This is now 2. So you now have you apply the chain rule twice. Sec 3 theta dot sec 3 theta tan 3 theta dot 3. So now your final answer here will now give you 3 e raised to power sec 3 theta sec 3 theta tan 3 theta. So let me write it boldly and clear. It's 3 e raised to power sec 3 theta sec 3 theta tan 3 theta. So this is the final answer for the example 9. Before we now, after the example 9, I now want to explain the derivative of general exponential function. In case you have question in this, please, I want you to study it. For any question so far, let me know. So I will now know what to do. In the comments, put your question in comment section. Put it in the comment section. So let me see. I will be able to tell you what to do next. So I'll give you what to do next. So let me now explain the. So what really we want to explain in example 10 is, you see these questions. It said derivative of general exponential function. In solving this, it said if y is equal to b raised to power x and dy dx will give you that's the same answer, log ln b. But in calculus, sometimes we call it a ln b. So now let's now solve this example. You don't need to waste your time. Just apply the formula and solve it. Let's see. It said solution. It said the g of x is equal to 2 raised to power x. So g of x prime will be, we write the same question and said ln 2. That's just the final answer. In approximations, we have 2 raised to power x. The ln 2 is 0, but that's the logarithm of 2. That's all. Just to multiply. That's all. In the solving the b part, if h of x is equal to 5s squared. So what you are going to do is, you said hx prime is, you firstly write it now dot ln 5 now dot derivative of s squared dx, because he has function inside the function. That is why we now have f of x onto 5 onto s squared ln 5 dot 2x. So the final answer will now be, you can't multiply anything because they are different things entirely. So 2x dot 5x squared ln 5. So this is where these areas you can face chain rule in calculus differentiation. This is where you can face it. This is how, from the beginning to the end, this is what we call chain rule. And I'm able to use this opportunity to explain better about chain rule. So once again, as we are ending this class about chain rule, don't forget, if all what we are doing is meaningful, don't forget to subscribe to the channel. All what we are doing here is meaningful to you, don't forget to subscribe to this channel. Top up the notification button on. Anytime I'm releasing a course, you're able to receive it for free. So I really appreciate everybody watching this video. So thanks for the watching and thanks for your times.